Hello everyone, myself B. Vijaya, lecturer in chemistry, working in Indira Priyadarshini Government Degree College for Women, Nampalli. We are discussing the chapter Coordination Compound and the classification of ligands. Classification of ligands, here the ligands are of two types. What are the two types? Based on the number of based on the number of donor atoms okay, based on the number of donor atoms the ligands are of two types. So actually what are the ligands are any atom, ion or molecule which is capable of donating a pair of electrons, right? Donate a pair of electrons to the central metal atom or ion called as the ligands. And here the they are of two types actually. These ligands are of two types. One is the neutral molecules, and another one is the anions, right? So the ligands are of two types, neutral molecules and anions, and the neutral molecules carries a lone pair of electrons, they carries. And here anions are nothing but the negative charge. If any atom or ion which carries the negative charge, so that is called as an anion. And neutral molecules are nothing but this which carries the lone pair of electrons. So that for examples are the water molecules. I will change the color so that yeah. So here the neutral molecules are H2O and ammonia, right? CO, etc. etc. These are the neutral molecules. Ethylene diamine, EDTA also comes under the neutral ligands only, which carries the lone pair of electrons. This is the very important thing here. Anions means the OH minus ion, right? And all the halogens like Cl minus, Br minus, fluoride minus, right? So all the halogens comes under the anions only, sulfate, nitrate, etc. Okay, so these are the anions. And here these ligands must carry either lone pair of electrons or the in terms of negative charges. So they must have the ability to donate the pair of electrons to the central metal ion. So here, based on this number of donor atoms. And what is the donor atom here? If you take any of them, means either neutral or anions, we can take. So any ligand we can take in which only one atom is having a ability to donate the pair of electrons to the central metal ion. So for example, here I am taking water molecule, and this water molecule hydrogens are attached to the oxygen, right? In this way hydrogens are attached to the oxygen, and this is a neutral molecule, right? So because the hydrogens are having a only one electron, and this one electron is also participated in the bond formation with the oxygen. So oxygen is having, I means it formed a two bonds by sharing its two electrons, and it is having a two pairs of electrons are there, right? Two pair of electrons are there, and it can donate one lone pair of electron to the central metal ion. Can donate a pair of electron to the central metal ion, and this oxygen here called as a donor atom, because only oxygen, not hydrogens, are donating, right? This in this molecule only oxygen is donating the pair of electrons to the central metal cation. That is the reason it is called as a donor atom. And if you take ammonia here, so NH3, and the bonds means three hydrogens are formed, the three covalent bonds with the nitrogen by sharing their electrons in this way, right? So here hydrogens are balanced their valencies actually, but here nitrogen is having a one pair of electron, one lone pair of electron is there in the nitrogen, and here the hydrogens are not acting as a donor atoms because they does not having any lone pair of electrons, they does not have anything to donate, but nitrogen is having a lone pair of electrons, and because of means it can donate the lone pair of electrons to the central metal ion, so that this nitrogen is called as a donor atom. And here in carbon monoxide, so there is a three bonds are there in the carbon monoxide, and one back bonding is also takes place from the oxygen to the carbon monoxide, and here this oxygen is having a one pair of electrons, right? One pair of electrons, and this oxygen is the donor atom to the central metal cation, which can donate the pair of electrons to the central metal cation, but not the carbon here. So in any molecule we can take, so only one atom or more than one atoms maybe if it is a monodentate ligands, and one donor atom is donating the pair of electrons to the central metal ion. So here for the monodentate ligands, only one donor atom is there, right? One donor atom. So it is the classification is based on the number of donor atoms present in the ligand. So all are in the neutral or anions. If you take, so all are not a donor atoms, right? Donor atoms. So this which are the donor atoms which are having a capability to donate the pair of electrons in this particular molecules or molecular ions. So that particular atom is called as a donor atom. So based on the number of donor atoms, uh, they are of two types. One is the monodentate ligand and another one is the polydentate ligand. So all these examples are comes under in the monodentate ligands are also. Examples are water molecules, ammonia, whatever I have given here. So CO molecule, OH minus molecule. In the OH minus molecule, oxygen is carrying the negative charge, but not the hydrogen, right? So oxygen is a donor atom, and all halogen ions and sulfate minus 2 in this oxygen can donate the pair of electrons, etc. So in monodentate ligands, only one donor atom can donate the pair of electrons, and they can form a only one one coordinate bond with the central metal atom, right? Only one coordinate bond with the central metal cation. So those are called as the monodentate ligands, and this monodentate ligands, they may have even more than one lone pair of electron also. See here in oxygen, two pairs of electrons are there, but it can form only one bond with the central metal ion. It can donate only one pair of electron to the central metal cation. So it is the irrespective of, means it is the how many number of lone pair of electrons may be present, but they cannot donate all the pairs of electrons. They can donate only one pair of electron, so that one coordinate covalent bond they can form with the central metal cation. One ligand can form a one coordinate covalent bond, right? So those are called as the monodentate ligands. And what are the polydentate ligands are? If the ligands are having more than one right? More than one ligand donor atoms, more than one donor atoms, then they are called as a polydentate ligand. Poly means here, what is the meaning of poly? Many. That means more than one, more than one. So it is greater than one, more than one. And dentate means what? Donor atoms. So more than one donor atoms present in the ligands. So those are called as a polydentate ligands. They also might be a neutral molecules or anionic molecules. And this polydentate ligands further classified into three types. One is the based on the symmetry. These are symmetrical and unsymmetrical, and ambidentate ligands. This is the one type of the ligands, and bridging ligands. Let us discuss one by one about them. And first one is a symmetrical ligands or unsymmetrical ligands. So first, before going to the symmetrical and unsymmetrical ligands, so the polydentate ligands are we already discussed polydentate ligands, right? The polydentate ligands are ethylene diamine and glycinato ion, GLY. It represents with the GLY, glycinato ion, and DMG, dimethyl glyoxime, right? Dimethyl dioxime. So these are the some certain types: EDTA, ethylene diamine tetraacetate acetate ion. Okay, ethylene diamine tetraacetate ion. So that these are the polydentate ligands are many are there. So in which some ligands are having a some means some symmetrical ligands are there, and some are the unsymmetrical ligands are there. So what is the symmetry of the ligand? Symmetrical ligands here, the example ethylene diamine, I am taking the example here. So better I will change the color. So ethylene diamine I am taking, sorry, okay, ethylene diamine, uh, this is INE. It represents with small en. Okay, in brackets, right? So ethylene diamine I'm taking. And what is the molecular formula of this ethylene diamine is very simple. Ethylene molecule CH2 and NH2. So here this is called as the bidentate ligand. Why it is a bidentate ligand? Because it is having a two nitrogen atoms, and the two nitrogen atoms are having a lone pair of electrons here, right? Lone pair of electrons, and they can donate the pair of their pair of electrons to the central metal ion at a time. So that is the reason it is a bidentate ligand. Bidentate ligand. Bi means two, right? Bi means two. Dentate means donor atoms. So the ligand which is having a two donor atoms are called as a bidentate ligand. So ethylene diamine is a bidentate ligand in which two nitrogens are there which carrying a pair of electrons. So this is one donor atom, this is one donor atom. They can instantaneously, means simultaneously, they can form a two bonds with the central metal ion. And if you see here, this is the symmetrical molecule. See here, what are the molecules are there? CH2 and H2. And this side also the same number of the atoms are there. So CH2 and H2. So this is a symmetrical molecule which is having a identical atoms on both the sides, right? Identical molecules are identical groups on both the sides. So it is following a symmetry. That is the reason this type of the ligands are called as a symmetrical molecules or symmetrical polydentate ligands. And another molecule, let us see now, glycinato molecule. So what is the glycinato molecule is, second example I am taking. Second here I will take, which represents with the GLY actually, and I will write glycinato ion. Glycinato ion. And what is the glycinato ion is? The molecular composition of glycinato ion is CH2 is there, only one CH2 is there, and at one side NH2. So this glycine is the amino acid, right? So NH2, CH2, C double bond O, O minus, right? So here this particular molecule is having a two uh, means two, one is the NH2 and another one is the carboxylate ion. So here this nitrogen is carrying a lone pair of electron and here oxygen is carrying a negative charge. So it can donate a pair of electrons to the central metal cation, and as per our definition of the ligands, so this oxygen is carrying a negative charge. So it can also can donate its electron pair to the central metal cation in the form of negative charges, right? So this negative charge is nothing but the pair of electrons only. So here oxygen can donate the pair of electrons, nitrogen. But here if you see, these two are not a identical ones. This is a NH2 is a different one and COO minus is a different one. So if you cut like this, there is no identical ligands are present on the both sides, so that which is the example of unsymmetrical one, unsymmetrical ligand. And this is also, since it is also having a two donor atoms, which is also a bidentate ligand, which is also the example of bidentate ligand. And the third example I am taking, since it is a symmetrical, right? Symmetrical ligand, symmetrical ligand. So on both sides uh, same type of the what donor atoms are present. And oxalato ligand, and this oxalato ligand is represents with, oh sorry, OX. I will rub this OX, right? So small o, small x. If you see the structure of the oxalato ligand, C, mm, C, double bond O, double bond O, and here O minus. This is the anionic bidentate ligand, right? Anionic. This is the anionic Because both the oxygens are carrying a negative charges. Anionic bidentate ligand. But if you break down this molecule into two, so this part is say mirror image of this part, isn't it or not? So these two oxygens can donate the pair of electrons in terms of negative charges to the central metal cation. So this is also a symmetrical bidentate ligand. Symmetrical bidentate ligand. So, what is a symmetrical ligand? Symmetrical ligands, if you just break the molecule into two, so one part means left hand side should be equal to the right hand side, whatever the number of, and they must have a similar type of the donor atoms on the both the sides. But in the glycinato form, glycinato ion, so here NH2 group is there, here carboxylate ion is there. So both are different from each other. That is the reason it is called as the unsymmetrical bidentate ligand. The next one is the ambidentate ligands. Ambidentate ligands are actually the ligands which are having a more than one donor atoms. More than one donor atoms they are having. Ambidentate ligands are having more than one donor atoms. So that is the reason they are the part of the polydentate ligands. But here the twist is, even though they are having a more than one donor atoms, but they can form they can form only one bond, only one bond. So only one bond they can form. Even though they are having a more than one donor atoms, they can form only one bond from either of the side. So the examples are, what are the examples are? Thiocyanate, NCS minus, right? Thiocyanate. So here the thio group is there which is carrying a negative charge, and here nitrogen is also having a lone pair of electrons. So it can form a bond or it can also form a bond. Uh, but unlike a polydentate ligands, other polydentate ligands, as of now we have seen, so they are forming both the bonds, right? So here two nitrogens are there, two nitrogens are forming the two bonds with the coordination, means the central metal cation. It is forming a two coordinate bonds at a time only. Here, the ligands may be different, but they are also forming a two bonds at a time. Here, oxygen ions are donating the pair of electrons to the central metal cation in terms of the negative charges at it is a single time only. So they are forming a two bonds at a time. But here, in this particular ambidentate ligands, they cannot form a more than one bond actually. So even it is having a two donor atoms. So nitrogen is a donor atom, sulfur is also a donor atom, as it is carrying a negative charge, right? It is carrying a negative charge, but here only one of these donor atoms can form a bond. So either of the side they can form a bond. That means, for example, in this particular molecule, it can means sulfur can donate a uh, pair of electrons to the central metal cation in terms of the negative charge, and it can form a thiocyanato complex. And in other way also it can form like the same ligand, only same ligand, NCS minus, So isothiocyanate also, by donating its pair of electrons to the central metal cation, it can also, nitrogen also can form a coordinate covalent bond, but they form only one bond only, even means it is having the two or more different donor sites, donor atoms may be present, but in a given time, means in a one complex they can form only one coordinate covalent bond. So from either of the sides they can form a bond, but only one bond only they can form. So here sulfur is not forming a bond with the central metal cation, and here nitrogen cannot form a bond with the central metal cation. So here sulfur is forming a bond. This type of the complexes are called as a thiocyanato complexes. Thiocyanato cyanato complexes. And if nitrogen is forming a bond with the central metal ion, so it is called as the isothiocinato isothiocinato complexes. Isothiocinato complexes, and this type of the ligands are called as the ambidentate ligands. The other example, this is the one example, and the second example is nitro group, that is NO2, right? NO2. So in this NO2, what is the molecular formula of NO2 is, sorry, nitro molecule is NO2, and the structure is in this way, O minus and double bond. So this oxygen is satisfied its valency with the nitrogen, that is the -2, right? So double bond, it has been formed, and this nitrogen is carrying a lone pair of electrons, and oxygen is carrying a negative charge. So here either oxygen can form a bond or the nitrogen can form a bond, but not these two cannot form a bond with the central metal cation at a time. So here the nitrogen, uh, if the nitrogen can donate its pair of electrons to the central metal cation and it can form a bond, it is called as a nitro compound. Nitro compound. So in which nitrogen atom is the donor atom now. So in this particular complex, nitro complexes they can form, in which nitrogen is the donor atom. And in the similar way, the same manner, NO minus and double bond O, and it is having a lone pair of electrons, but now the oxygen is donating the pair of electrons to the central metal cation. So if oxygen can donate the pair of electrons to the central metal cation, this linkage means a OM linkage or MO linkage. So this is called as a nitrito complex, nitrito ligand. So this is called as a nitrito ligand. So this kind of the molecules are called as the ligands, are called as ambidentate ligands, even they are having a more than one donor atoms, but they can form only one bond at a time. At a time, they can form only one bond. So this is a very important one, especially for the students, those who are preparing for the entrance examination. So nitrito and nitro, isothiocyanate and thiocyanate. In thiocyanate, sulfur metal linkage will be there. In isothiocyanate, nitrogen and the metal linkage will be there. In nitro molecule, so metal nitrogen molecule linkage will be there, and in nitrito, oxygen metal linkage will be there. The next one is the bridging ligands. So what are the bridging ligands are? This all the remaining means polydentate ligands. These polydentate ligands are of different types based on the number of donor atoms again. If the two donor atoms are present, two donor atoms are present. So in the ligand, these are called as bidentate ligands. Bidentate ligands. So as we have seen just now, that is the ethylene diamine, right? Oxalato ion, glycinato ion, and the next one is the DMG dimethyl glyoxine, right? So all these are the examples for the bidentate ligands. Two donor atoms they are present. If three donor atoms are there. If the three donor atoms are there, those are called as the tridentate ligands. Tridentate ligands. The tridentate ligands are diethyl, um, diethylene triamine, diethylene triamine, triamine. So this is a unsymmetrical molecule. Diethylene and triamine is a unsymmetrical molecule, even though it is having a the same type of the donor atoms. Three amine groups are there, but it is a unsymmetrical diethylene triamine molecules. So which represents with the diene, okay, diene. And the molecule is what is the structure of the molecule is CH2, CH2, and this is having a NH2, is connected to NH2, CH2, CH2, and NH2. So sorry, this is only one hydrogen here. It has to balance its valency, right? So NH. Okay. Now the metal ion is inserted here, and this nitrogen can donate its pair of electrons, and this nitrogen can also donate its pair of electrons, and this nitrogen also can donate its pair of electrons. So this one ligand is forming the three bonds at a time, three bonds at a time. So which is having a two ethylene molecules and three ammonium molecules. So three amine molecules are there. So it is the name of this molecule is this is having a three donor atoms and tridentate ligand, and this tridentate ligand is the structure it is. So this is a unsymmetrical, even though it is having a same type of the donor atoms, right? Unsymmetrical. This is the example of the unsymmetrical ligand. If if four donor atoms are present, these are called as the tetradentate ligands, right? Tetradentate ligands. What is the example for the tetradentate ligand? Similar to tridentate ligand, here the triethylene tetraamine. So triene, it is called as the triene. It is represents with a triene, and the name is triethylene tetraamine, tetraamine, and which represents with triene. So what is the structure of this triene is? What is the structure of triene is? So CH2, CH2, which is having a bond with the NH, and this is NH2, and now CH2, CH2, and NH. This is having CH2, CH2, NH2, right? So now see here how many ligands are there, how many donor atoms are there. This is the one donor atom, Nitrogen, because nitrogen, this is having a lone pair of electrons. This is the second donor atom which is having a lone pair of electrons. Third donor atom, because it is having a lone pair of electrons, and fourth donor atoms. And all these donor atoms can donate their pair of electrons to the central metal cation and can form a four coordinate covalent bonds at a time with the central metal cation. At a time, four bonds they can form. Right, so that is the reason it is a tetradentate ligand. What is the tetradentate ligand? Three ethylene diamine molecules are there. So three ethylene molecules are there. So it is called as a triethylene and tetraamine. 1, 2, 3, 4. Tetra means 4. So tetraamine, tetraamine ligand. So triethylene tetraamine is the example for this. So the next one is the pentadentate ligand. So pentadentate ligand. So pentadentate ligand means what? Which is having a four donor atoms. Pentadentate pentadentate ligand, which is having a five donor atoms. Five donor atoms are present. Five donor atoms are present. And what is the example for that? Ethylene diamine acetato triacetato ion. So what is the example? What is the example for that? Ethylene diamine ethylene diamine triacetato triacetato ion. Triacetato ion. So what will be the structure of this particular molecule is the structure of the particular molecule, ethylene, right? Ethylene means CH2CH2. Diamine means NH, right? Two nitrogen atoms will be there and three acetato ions will be present. Three acetato ions. Acetate group is nothing but CH2COO minus, right? So before that I want to rub this structures. Okay, so ethylene, first one is the ethylene, CH2 CH2, and diamine means two nitrogens will be present, two nitrogens present, and triacetato ion, triacetato ion, that means here acetato group is CH2, C double bond O minus, right? And here one hydrogen will be there. And this is one acetate group and this is NH group, and here CH2, C double bond O, O minus, this is one, and here this is CH2, C double bond O, O minus, right? So now you see now how many donor atoms are there here. This is one donor atom. Okay, this is second donor atom. As oxygen is carrying a negative charge, here nitrogen is carrying a lone pair of electrons, here nitrogen carrying a lone pair of electrons, and oxygen is carrying a minus charge. This is the third ligand, third donor atom. This is the fourth, and this oxygen which is carrying a negative charge, this is the 5. So, if the central metal ion is there, so it can form the covalent coordinate bond with the central metal cation by donating their pair of electrons, and this oxygen atoms, 3 oxygen atoms also can donate the pair of electrons to the central metal cation and can form a coordinate covalent bonds. So total how many donor atoms are there? 5 donor atoms are present, and each donor atom can form a bond uh, bond with the central metal cation at a time only. So these are called as the bridging ligands. These are called as a bridging ligand. See here, this nitrogen to this oxygen, there will be some bridge like structure, right? So the coordinate covalent bond to this one. So it is bridge-like structure. So that is the reason these are called as the bridging ligands. And the next one will be the hexadentate ligand. Hexadentate ligand, in which total 6 donor atoms present. 6 donor atoms present. Those are called as a hexadentate. 6 means hexa, right? Hexadentate ligand, and the best example is EDTA. EDTA. The name of EDTA is ethylene ethylene diamine tetraacetate. Tetraacetate. Okay, tetraacetate ion. Tetraacetate ion. Okay, tetraacetate ion. And here, similar to this structure, the ethylene diamine. So ethylene means one ethylene group is there, CH2, and here diamine means 2 nitrogens are there, and which they are having a acetate group, CH2CO minus. Okay, and this nitrogen is also having a CH2, COO, C double bond O, O minus, and CH2, C double bond O, O minus, and CH2, C double bond O, O minus, right? So now you see how many donor atoms are present. So this oxygen carrying a lone pair of electrons, it can readily donate the pair of electrons to the central metal cation, so that it is 1, and this is the 2 second oxygen, and since this nitrogen is having a lone pair of electrons, so that it is can donate the pair of electrons to the central metal cation, and this is the 3 and this is the 4, and this oxygen will be 5, and this oxygen carrying a negative charge, so it is a 6. So to the central metal cation, one EDTA can form, single EDTA can form 6 bonds around the central metal cation. So it is completely cage-like structure, right? Cage-like structure around the central metal cation, and which is acts as a best chelating agent for the any central metal cation. So these are called as, all these polydentate ligands are called as the bridging ligands, like they are forming a bridge between the two coordinate covalent bonds, right? So that is the reason these are called as the bridging ligands, in which polydentate ligands in which the 2 donor atoms are present, so it is called as a bidentate ligand, and 3 donor atoms are present, it is called as a tridentate ligand. 4 donor atoms are present, it is called as a tetradentate ligand, and pentadentate ligands means 5 donor atoms will be present, and 6 donor atoms is present, those are called as the hexadentate ligands. So this is about the classification of the this ligands, and here the same thing with the same examples I have given for you. I have explained the classification of the this ligands, polydentate ligands, especially these are the bridging ligands, right? Bridging ligands with the examples.